Here we have a SAT math problem. Okay, let's go to the question. In the triangle above, cosine A equals to sine B. If the length of AB is 20 and the measure of angle B is 5 over 3 radians, what is the area of the triangle? Okay, here we have that cosine A equals to sine B. Whenever the two trigonometric ratios cosine and sine are equal, then the angle measure we have for cosine, the angle measure we have for sine must be complementary. That is, these two angle measures A and B must be complementary. That is, A and B must add up to 90 degrees. Okay, and also we have the measure of angle B, that is 5 over 3 radians. For my convenience, let me convert this radians to degrees. Let me write over here. To convert this radians to degrees, I have to plug in 180 for pi. Then I'm getting 180 over 3, that is equal to 60. That is 5 over 3 radians equals to 60 degrees. So this 60 degrees is the angle measure for B. Now we can plug in this 60 for B over here. Then I'm getting A positive 60 equals to 90. Let me subtract 60 from both sides to solve for A. Then 60 negative 60 will cancel. A equals to 90 negative 60. I'm getting 30. Okay, now I've got the angle measures, this lowercase a and lowercase b. So the angle measure lowercase a is 30 degrees and the angle measure lowercase b is 60 degrees. In any triangle, three interior angles will add up to 180 degrees. We know that the sum of these two interior angles equals to 90 degrees. Then the measure of this angle must be 90 degrees, that is right angle. So that these three interior angles will add up to 180 degrees. So clearly ABC is a right triangle and also it's a special right triangle, that is 30, 60, 90 special right triangle. Okay, in this 30, 60, 90 special right triangle, the side of the triangle which is opposite to the smallest angle measure is the shortest leg. Okay, here CB is the side which is opposite to the smallest angle measure 30 degree. So this is the shortest leg. Usually we assume X as the shortest leg of this special right triangle. And the next longer leg is the side which is opposite to the next larger angle 60 degree. Here AC is the side which is opposite to the next larger angle 60 degree. This is the next longer leg. Now to get the length of this leg which is opposite to 60 degree, we have to multiply the length of the shortest leg X by square root of 3. That is, we get X times square root of 3 as the length of AC. Now to get the length of the hypotenuse, the side which is opposite to the right angle, we have to multiply the shortest leg X by 2. That is 2x. Okay, now we have the lengths of all the three sides of this right triangle in terms of x. But already we have the length for the side AB, that is hypotenuse. It is given over here 20. So here let me write 20. So this 2x and this 20, both of them represent the length of the side AB. We can equate them. When I equate this 2x and 20, what value do I get for x? Let me do it. 2x equals to 20. Let me divide both sides by 2. When I do so, this 2 will cancel. I am getting x equals to 20 divided by 2 is 10. Okay, now I got the value of x, that is 10. So now let's plug in this 10 for this x over here and here. Okay, when I plug in x equals to 10 over here, I am getting 10. That is 10 is the length of the leg BC of this triangle. When I plug in x equals to 10 over here, I am getting 10 times square root of 3. So 10 square root of 3 is the length of the leg AC. Okay, our aim is to find the area of the triangle. Okay, let me write the stuff over here. Area of the triangle equals to, we know the formula to get area of the triangle, that is 1/2 times base times height. Okay, here we must be knowing the base and height to get the area of this triangle ABC. Okay, here it's a right triangle. In a right triangle, apart from the hypotenuse, in the remaining two legs, one of the legs can be considered as the base and the other leg can be considered as a height. Okay, here AB is hypotenuse. Now let's consider the remaining two legs of BC and AC. So here we can consider this BC as the base of the triangle and AC as the height of the triangle. Okay, when I do so, 1/2 times for base we have 10. We can plug in 10 for base and the height 10 times square root of 3. Okay, here 2 goes into 2 1 times and 2 goes into 10 5 times. Then we have 1 times 5 is 5. 5 times 10 square root of 3 is 50 square root of 3. Therefore, the area of the given triangle is 50 times square root of 3. We find this stuff exactly in answer choice C. The correct answer choice for this question is C.